Hey guys, we're back here with the next couple tangent ratios, 9.5, the sine and cosine ratios. We're going to be doing pretty much the same kind of thing we did with the tangent ratio as with these ratios as well. We're using them, we're going to be finding some sine and cosine angle measures and also solving some real life problems with those. So before we get started, let's go ahead and just take a little look at a Far Side cartoon again. So you got this guy sitting on this little deserted island, one palm tree there, and finally some spacecraft flying saucer comes by, and he thinks he's saved, but actually it was just them coming to collect their friend, the other palm tree. So two palm trees came to collect the other palm tree. So left him all by himself, and now he has no shade. Alright, let's go on to the core concept of the sine and cosine ratio. So page 264 in your notes, we'll see the sine and the cosine both deal with the hypotenuse. So remember the ratio for the tangent did not deal with the hypotenuse. It was just opposite over adjacent. So it's always going to be a ratio, something over something here. For sine and cosine, it's going to be over the hypotenuse. Sine is going to be the opposite over the hypotenuse, and the cosine is going to be the adjacent over the hypotenuse. And so that's what we can see here if we have a right triangle. Remember, we're always dealing with right triangles with trigonometry. So if we're looking for like the angle measure of A and we're looking for the sine of that, it's going to be the opposite over the hypotenuse. So this number over this number. The cosine would be the adjacent over the hypotenuse, so this number between A and C over the hypotenuse. So just like for the tangent, if we look at sine, we usually abbreviate it SIN, like sin. That's going to equal opposite, OPP, over hypotenuse, HYP. Usually we just say those three letters, OPP over HYP. And so that could actually be called the opposite over hypotenuse. So that's the SOH. So SO and H. So that's what that kind of refers to as a acronym. And we just usually say SO for that one. And for the cosine, we usually abbreviate just COS. And that's going to be adjacent, so ADJ over HYP. And we can then go off of acronyming this one, COH, or sorry, say CAH, I don't remember the alphabet, CAH, and that's usually Ka. So and Ka, and remember the tangent was tangent opposite of adjacent, and that's TOA, TOA. So the three together would be So, Ka, TOA. We'll look at that there at the end of this lesson. Alright, so moving on, let's try a couple of our extra practice. Okay, so on page 265, we're doing finding the sine of f and g, then the cosine of f and g of each of these right triangles. It wants us to write our answer as a fraction and as a decimal, rounded to 4 places. So starting with number 1, let's go ahead and start with the sine of g. So if we're looking at where g is, that's going to be sine of g, remember, is going to be opposite over hypotenuse, so OPP over the HYP. And so it's going to be opposite, which is 5, over the hypotenuse, which is going to be 13, or the hypotenuse is always opposite the right angle. So 5/13 is our fraction. That's what our first thing is right as a fraction. And now as a decimal, we can do this as a decimal here, 0.3846. So we could see that on the calculator real quick, just if I just did 5 divided by 13, that's how we're getting this decimal. Just that, we're not using any sine buttons or cosine buttons on this yet. Just dividing 5/13 as a decimal, there's your decimal, 0.3846 to 4 decimal places. Sine of f. This is going to be adjacent, or opposite over hypotenuse again, so same kind of thing though. So 12/13, so if we're going off of f, opposite of f is 12, and then there's the hypotenuse again is 13, so 12/13. And I'm not going to do the calculator for every single one. You understand what I'm doing. Just to go a little faster, our decimal there is going to be 0.9231. You can go ahead and divide 12 divided by 13, and that would give you that decimal. And now for cosine of g, that's going to be the adjacent over the hypotenuse. So now we're looking at g again. Adjacent is going to be next to g here. So that's the side here. It's 12, and it's over 13. So this one's going to be 12/13, which will have the same decimal as that one as well. So you don't have to redo that one on the calculator. You just go ahead and copy it, 0.9231. And then the cosine of f, that's going to be, again, adjacent over hypotenuse. So f, adjacent, is next to. So 5 is next to f here, and it's over 13, the hypotenuse. 5/13 will give you the same decimal up here. Is that 0.3846? And so what you might be noticing is that we have some things that are the same. So the sine of g and the cosine of f were the same with these two. So basically you have your two acute angles in here, and so the sine of one and the cosine of the other are going to be exactly the same. So that's one thing you might keep in mind. So number 2, as we start to go off of this one, sine of g first. So you can see where the g is, opposite is there. So 72 is over the hypotenuse. Hypotenuse is opposite right angle, that's 97. So opposite over hypotenuse, so it's 72 over 97. We can go ahead and divide on our calculator, 72 divided by 97 to get our decimal, and there it is, 0.7423 if we round that up. So that's what we want to see on that one. And then the sine of f, same thing with the opposite over hypotenuse. We're going from f, so 65 over 97 this time. And we divide that one on the calculator, we will get 0.6701. And then doing the cosine of g, so cosine of g would be adjacent, that's the 65 over 97, so it's going to be the same as the sine of f. So 65 over 97, which is 0.6701. And then we're going to do the cosine of f. So the cosine of f, so adjacent to that 72, so that's the 72 over 97, it's the same as the sine of g. So 72 over 97 is that 0.7423. So go ahead and try this next one, number 3. Go ahead and stop the video for a minute and try that third one, and then come back and see that you got that correct. Alright, so you should be completed with 3. Let's go ahead and just check your answer. So the sine of g on this one, so g is going to be here, so we're going to be square root of 2 as the opposite, over hypotenuse is 2. And so there you got it. The decimal form of that, we're going to need to do the square root of 2 on the calculator, so you just do 2 square root and then divide by 2, and there's your decimal, 0.7071. That would be our decimal on that one. And then sine of f, so f is over here. It's going to be exactly the same thing because these are both square root of 2's here, so opposite of f is going to be the same. So square root of 2 over 2 is going to give us that same decimal. And then, so that means that going off of the cosine of these, cosine of g is still going to be square root of 2 over 2, which is going to be the same decimal. And the cosine of f is still going to be square root of 2 over 2, which they're all going to be the same decimals. These are all exactly the same. So basically what we had here is a isosceles right triangle. And so when you have an isosceles right triangle, the cosine and the sines will all be the same on that one. Okay, so at the top of page 265 we have this thing called the sine and cosine complementary angles, and it really is kind of what I was just talking about and what we kind of noticed from the pattern there. It's just telling us, well, A and B here are the other two acute angles, where C would be the right angle, A and B are the complementary angles. They would add up to 90 degrees. And so what we could see here is that, sine of A is going to be the same as the cosine of B, or cosine of A is the same as the sine of B. That's what we were noticing. And so that's kind of what we're looking at here. And the reason is because you could do this as the sine of A is the cosine of 90 degrees minus A, which would be what the cosine of B would be. So really just to remember what we were just talking about in the pattern that we saw, sine of A is the same as cosine of B. And so we can just remember that's what this is called, the sine and the cosine complementary angles. Okay, so back to the extra practice. The bottom of 265 is 4 through 6, and since we were just doing the complementary angles thing there that we were just talking about, the sine of 9 degrees. So it says write the expression in terms of cosine. So we have these 3 problems, 4 through 6 are all in terms of sine. We want to write it in terms of the cosine. So we're going to say, okay, the sine of 9 degrees, that's the same thing as saying the cosine of 90 minus 9, because A is 9 degrees, what we're talking about here. And so 90 minus 9 would just be 81. So it's the same thing as saying cosine of 81. So you can just see these are complementary. 9 degrees and 81 degrees add up to 90 degrees. Sine of 30, so you can see that would be sine of 30 degrees is going to be 90 minus 30. So cosine of 90 minus 30 would be the cosine of 60 degrees. Go ahead and just write down the next one here. You can do that real quick. I'll pause for a minute. You can pause the video. You should have just said 90 minus 77 for the cosine, and 90 minus 77 is 13. So cosine of 13 degrees. 77 plus 13 is 90. And if you turn the page now in your notes, at the top of 266, you'll see 7 through 9. And you're going to do essentially the same exact things. Go ahead and pause the video, and I'll let you try these three on your own. We're just starting with cosine and then writing it in terms of sine. So it's exactly the same thing we just did. So go ahead and pause the video and then play it as soon as you're done with these three. Alright, so you should be completed with 7 through 9. Let's just go ahead and just check to see that you did these correctly. So cosine of 15 degrees is going to be the sine of 90 minus 15. And 90 minus 15, that's 75. So sine of 75 degrees is that. So the cosine of 15 degrees is the same thing as the sine of 75 degrees. Cosine of 83, that's going to be 83 minus 90. The sine of 83 minus 90, or 90 minus 83. And then so 90 minus 83 is 7, so the sine of 7 degrees is the same thing as the cosine of 83. And then the cosine of 45, 90 minus 45 is just 45, so we can just say, well, it's, sine of 45 degrees is the same as the cosine of 45 degrees. That would be like a isosceles triangle right there on that one, that they'd be exactly the same. All right, we'll pause for a minute and have a little joke of the day. So here's our joke of the day. A mom texts, "Hi son, what does IDK, LY, and TTYL mean?" He texts back, "I don't know. Love you, and talk to you later." The mom texts him, "It's okay, don't worry about it. I'll ask your sister. Love you too." She didn't get that he was telling her what they really meant. Okay, so here it says find the value of each variable using sine and cosine. So continuing on with our extra practice number 10, we're trying to find x and y here using sine and cosine. It tells us this angle right here, this acute one, is 16 degrees. So the x would be opposite of that. So we would use the sine to find x. So we could say the sine of 16 degrees is equal to opposite over hypotenuse. That would be x over 9. So it's equal to x over, I put 16 down here. That's my mistake. I'll probably have to go back and redo this one. Okay, so yes, it should have been fixed there with x over 9. So that's what our sine should have been here, opposite over hypotenuse. And so now we want to solve the equation 4x, just like we were doing those tangent ones. We're going to multiply both sides by 9, so 9 is going to multiply the sine of 16 degrees. So we'll see 9 times the sine of 16 degrees is equal to x. So just now we would use our calculator, and we would say on our calculator we have to put in the sine of 16 degrees first. So this calculator you have to put the number in first, 16, and then hit the sine button. The other ones in class we have to push the sine button, then hit 16. And then we just say times 9, so times 9 now, and there is our answer to the nearest tenth, 1 decimal place. So we're going to round this up to 2.5. That will be our answer on that one. And it's approximately, so we put approximate symbols on that, not the equal sign necessarily. And then the next one we're trying to find y, so that's going to be adjacent to this one. So now we're going to be using cosine. So cosine of 16 degrees will be the y over 9. So cosine of 16 degrees, y over 9, multiply both sides by 9 again. And so we're going to figure out the cosine of 16 degrees and times that by 9 to find the y. And so on our calculator we would hit 16 again. So hit 16 first, hit the cosine button, COS, and that gives us that big long decimal. And then we want to just multiply this by 9, so times 9, and our answer is going to be right there, 8.7 if I round that up to 1 decimal place. So it'll just be 8.7 then. So 11, we're looking at 72 degrees here, and we're trying to find m and n. So we can find the opposite of 72 is n, and our hypotenuse there is 50, opposite the right angles, that's our hypotenuse. So we can use sine for the opposite to find the n. So sine of 72 degrees is going to be n over 50. And then we're just going to multiply both sides by 50 again, just like we saw before. And so now we're going to see sine of 72. So I'll let you go ahead and just do the rest of this problem. Use your calculator to find the sine of 72. You can use it there on the computer or use your own calculator, and then times it by 50 to get n. Then do the same thing with finding m. Use the cosine, because that's going to be cosine on that one. So pause the video, finish 11, and then start the video again. Okay, so you finished number 11. So sine of 72 times 50, that should have given you a decimal of 47.6. If that's not what you got, then go back to your calculator and see what you did incorrect then, and make sure you get 47.6. Then we want to see cosine of the 72 degrees. That's going to be m over 50, adjacent over hypotenuse, and then multiply both sides by 50. So cosine of 72 times 50, use your calculator for that. You should get the answer of 15.5. Again, if you didn't get that, go back and see what you did to make a mistake. Number 12. So now we're looking for D and C. On this, we're told 47 degrees is here. We have opposite that we're trying to find, and we also have hypotenuse that we're trying to find. So in this case, we're going to want to use the cosine first, because that's where 10 is. 47 is adjacent to the 10, and so we want to use cosine first with this hypotenuse. We'll find the hypotenuse first here. So we're going to start with cosine of 47 degrees would be adjacent over hypotenuse, that's 10 over d. And so now d is at the bottom, and what we need to do here is pretty much just change places with d and the cosine of 47. Remember, we talked about that when we did the tangent. If your variable is on the bottom, you can kind of just switch places with that cosine or the trig function here and your letter. So d is going to equal 10 over that cosine. And now we just need to use our calculator for this. 10 divided by the cosine of 47. So let's come up here and do 10 divided by 47 and hit the cosine button. And there it is. And then we should hit equals and get our answer on this one. 14.7 is what we would see here on this one. So 14.7 is what we're getting for letter D. So now that we know that D is 14.7, we can use that as the hypotenuse now to find C. Now there is another way we could find C. We can use the tangent ratio, because we could do opposite over adjacent for tangent ratio. We can do the tangent of 47 degrees as opposite over adjacent. So there's another option for you as well using tangent. But they want us to use the sine and the cosine on this one, so we will just continue to do that. So the sine now of 47 will be the C over the 14.7. So we're going to use the sine of 47 degrees is going to be C over 14.7. And so now we can multiply both sides by 14.7 like we did before. Sine of 47 times 14.7 should be approximately, if we do this in the calculator, 10.8. So approximately 10.8, sine of 47 degrees, and then times it by 14.7. Alright, so on our next one, you're looking for, again, the same thing with the hypotenuse and a side here. So you have the opposite one here. You have 65 degrees, the opposite one. I'll let you try 13. 13 is a lot like 12. So pause the video, work on 13, and once you're finished, then go ahead and play it and see if you did that correctly. Okay, your 13 should be done at this point. So let's start with finding, using the sine, let's find the hypotenuse. So sine is going to be opposite over the adjacent. So we'll start with sine of 65 degrees is going to be 28 over b. That's the opposite over adjacent. And now we can kind of switch places there with the b and that sine of 65. So b is equal to 28 over the sine of 65. And then we want to hit 28 divided by sine of 65 on our calculator, and the decimal you should get there to one decimal place is approximately 30.9. You can go back and check your calculator work if that's not what you got there on your calculator. Now that we know that B is 30.9, we can now go into our next one. So cosine of 65 degrees. Cosine is going to be adjacent over the hypotenuse. That's going to be A over our 30.9. And so now we can multiply both sides by the 30.9. And on our calculator, hitting cosine of 65 degrees times 30.9 should give us approximately 13.1. So 13.1 should be our answer for that one. All right, so that's the main ones of our lesson are here. We're going to go on to looking at some kind of real life problems now, a couple of those there at the end of this lesson. Okay, so back on page 264, I believe, is where your vocabulary is, and there's a vocabulary here we need to look at, angle of depression. So it says, and we use this for real life problems here, so it says, recall from the previous lesson that the angle an upward line of sight makes with a horizontal line is called the angle of elevation. That was the basically the vocabulary of the last lesson. So this lesson, the angle of depression here, the angle that a downward line of sight makes with a horizontal line is called the angle of depression. So that's what you can write there for this one. It's just the angle of depression is the angle that a downward line of sight makes with a horizontal line. And so basically to see the difference there, so the angle of elevation, if I was going to have our little stick figure guy here, and here's maybe some tree over here or something like that, and he's this far away from it, from the tree. The angle of elevation would be right here. This is our angle of elevation, that line of sight going up to there. So your angle of elevation being right there, that angle, the line of sight for that. So there's your horizontal line. That's the horizontal line is the ground in this case. Here's one where the angle of elevation here is this. The horizontal line is actually an imaginary line straight out. So this skier, if you look straight out from here and go straight down at a right angle, that's kind of a line of sight there. But this will be your angle of depression. Okay, so an angle of depression also could be true there. All right, so this is kind of what I'll just show you this one real fast with this skier. It wants you to find, it says, you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance x you skied down the mountain to the nearest foot. So what's the distance from basically here down to here? And so our angle of depression is 21 degrees. We're trying to find x, so you can figure out, well, you have opposite over hypotenuse is what that would be. And so here it is. Sine of 21 degrees is going to be the opposite over the hypotenuse. Plug that in as 1,200 over x. And here's where you want to switch those, x and the sine of 21 degrees, basically. So you can see it's going to look like this now, 1,200 over the sine. And then just use your calculator to divide that like we did before to get your answer. So you can see that's what it's going to be there. So you ski about 3,349 feet down the mountain. Okay, so here we are with 14. A camera attached to a kite is filming the damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. So again, I would just do a little sketch of this. So you got your little guy here, a little stick figure guy. You can go put him down. We need the ground from him down to the closed-off area where it's going to be. So you want the ground there. And he's holding a camera on, or actually he's holding a kite. At the end of the kite, it has a camera attached to it. So we can have that. There's the kite going up there. Camera's there at the end. And it says that the camera is directly above the center of the closed-off area. So let's say the closed-off area is over here, and it's going to be directly above it. So it's going to be a right angle to the ground right there. It says a person that is standing 100 feet away from the center of the closed-off area. So This is 100 feet away here. So that's going to be 100. He's 100 feet away from the closed off area. The angle of depression from the camera to the from the person flying the kite is 25 degrees. How long is the string of the kite? So what we're trying to find is how long the string of the kite is. That's our x. The angle of depression here would be our angle here that it makes. Here's your horizontal line. Here's that line of sight going up. So it's going to be 25 degrees there. So again, we're trying to find just x. So we're going to use our trig ratios here. So we have from 25 degrees, this is adjacent here, and that's the hypotenuse. So adjacent over hypotenuse, we would use the cosine trig ratio. So we're going to have the cosine of 25 degrees is equal to 100 over x. And here's where we can again just switch places with the cosine and the x there. So x is equal to 100 over the cosine of 25. We can go ahead and just use our calculator for that. We could say 100 divided by, I got to hit 25 and then cosine. So there's the cosine of 25. And now if I hit the equal sign, I'll get the 100 divided by the cosine of 25, which is 110.3. And I think, did it say anything about decimals? I didn't say anything about decimals necessarily, but let's just use a 1 decimal place like we did before. So just 100.3 feet. And then letter B says, if the string of the kite is 20 feet long, how far away must the person flying the kite stand from the center of the closed-off area, assuming the angle of depression, they have the same angle of depression as 25 degrees to be able to film the damage. So let's go ahead and draw our little diagram one more time. So there's your guy again, the ground, the kite going up. So this is 25 degrees here, but now we're told that the string is 200. So that's our hypotenuse, is 200. We're trying to find how far away does he have to stand. That would be the ground. We're trying to find that there on this one. Still have the 25 degrees for the angle of depression. So now this time we're going to need to be doing, again, x over 200. That's going to be still adjacent over hypotenuse. We're still going to be using the cosine of 25 degrees. But this time it's going to be x over 200. That's what it will equal. And now we would just multiply both sides by 200. So we're multiplying the cosine of 25 degrees by 200. And so on our calculator we could do that real fast. So again, let's put in the, I'm going to hit 25 and the cosine. Get that number, there's that cosine of 25, and then times it by 200, and it equals 181 point, let's round that up to 3, so 181.3 feet away. That's how far he has to stay away from that to be able to film that damage. Alright, so that concludes our lesson here on 9.5. So go ahead and finish up. You want to be working on the big ideas assignment, and then I will see you in class. Have a good day.